This is section 12.1, part D, confidence intervals give more information. As with inference about means, a two-sided test at significance level alpha and a 100 times 1 minus alpha % confidence interval for the slope of beta leads to the same conclusions about the null hypothesis. That is because both inference methods use the standard error of the slope, or the SE sub b, in the calculations. The connection between one-sided tests and the confidence intervals for beta is familiar too. Our one-sided test at alpha equals 0.05 in the crying and IQ example gives the same conclusion as the null hypothesis for a 90% confidence interval for beta that we calculated in the previous section. Our bodies have a natural electrical field that is known to help wounds heal. How does changing the field strength affect healing? A series of experiments with newt investigated this question. In one experiment, the two hind limbs of 12 newts were assigned at random to either experimental or control groups. The electrical fields in the experimental limbs were reduced to 0 by applying a voltage. The control limbs were left alone. Researchers measured the rate at which new cells closed a razor cut in each limb in micrometers per hour. So an examination of the data suggests that the conditions for performing a regression inference are met. They've already checked all of those conditions. A 95% confidence interval for the slope beta of the true regression line for predicting healing rates in newts' limbs when exposed to 0 voltage from healing rates in their limbs with normal electrical fields is from negative 0.42 to 0.72. Based on this interval, what conclusion should we draw for a test of the null hypothesis of beta equals 0 versus alpha? The alternative hypothesis is beta does not equal 0 at a 0.05 significance level. Justify your answer. So because this is a two-sided test, and we know it's a two-sided test because it is not equal to. If we do 100 minus our alpha level, that'll tell us what confidence interval should match. So 100 minus 5 gives us 95. So the 95% confidence interval will match what the alpha equals 0.05 significance level would tell us. And since we're going from negative 0.42 to a positive 0.72, 0 would lie somewhere between those two numbers. So the 95% confidence interval includes 0 as a plausible value of the slope beta of the true regression line. At the alpha equals 0.05 level, we would fail to reject the null hypothesis that beta equals 0 and conclude that this experiment provides insufficient evidence of a linear relationship between healing rates and newts' limbs when exposed to 0 voltage and healing rates of the limbs with normal electrical fields. So far, we have used computer regression outputs when performing inference about the slope of population regression lines. The TI-83 or 84 can do the calculations for inference when you are provided with the sample data. And again, we can only do this if we have the sample data itself. So let's use the data from the non-exercise activity and the fat gain study from page 749 in the book. So what we would do first is we would enter the non-exercise activity values or changes in list 1, and we would list the fat gains as the Y values in list 2. To do a significance test, you're going to hit the stat button, and you're going to go over to test, and we're going to choose option F, which is a linear regression t-test. In the linear regression t-test screen, you're going to adjust the input as shown. So you need to make sure your X list says L1, your Y list says L2, your frequency can just be left as 1, and then you have to select what your hypothesis will be. So ours for this case is not equal to 0. It could be less than 0 or greater than 0, depending on what your alternative hypothesis would be. Then we're going to go down to highlight. If you want to store that regression equation, we can do that as well, but we can go down and calculate and hit enter. The linear regression t result take two screens to present. So you'll have two separate screens. At the beginning of the screen, it's going to tell you your alternative hypothesis, what it was. It's going to tell you the t-value, it's going to tell you the p-value, and it's going to tell you the degrees of freedom. Then it's going to tell you for your regression line what the letter value for A is. If you scroll down, it'll tell you the slope or your B value. It'll tell you the S, the R squared, and the R value. So let's compare these results from the mini-tab regression output below. We know that our constant or our A value, those two match. Our slope matches. Our T value for the slope is the same. The P value, this says 3.8 times. This means 10 raised to the negative fourth. So our P value matches because we are going to have three zeros. The R squared is the same, and the S value is also the same. To construct a confidence interval, you would hit Stat, you're going to go over to Test, and you would select option G, which is Linear Regression T-Interval. In the Linear Regression T-Interval screen, make sure you adjust it so you tell it that X list is list 1, Y list is list 2, our C level, your confidence level, you're going to have to change, and then you can calculate. And the linear regression T-interval will also take two screens to present, but only the first screen is shown below. So it's going to tell you the interval first, and then it will tell you the values for the slope, the degrees of freedom, the S value, and the value for A for our equation. So let's check our understanding. In Chapter 3, we examined data on the body weights and backpack weights of a group of 8 randomly selected 9th grade students at Webb schools. Some mini-tab output for the least squares regression analysis for these data is shown. Do these data provide convincing evidence of a linear relationship between pack weight and body weight in the population of 9th grade students at the school? Carry out a test at the alpha equals 0.05 significance level. Assume that conditions for regression inference are met. So since these are already met, that means our plan is going to be a lot shorter, but this is going to be a 4-step problem. So first thing we need to do is our state. Remember, in the state, you are going to give the null hypothesis, the alternative hypothesis, and then define the parameter. And you are also going to give the alpha level. So we want to perform a test of H sub 0 is beta equals 0 versus H sub A, beta does not equal 0, where beta is the true slope of the population regression line relating body weight to backpack weight. And we're going to use alpha equals 0.05. Next is our plan. This is where you say what method you are going to use, and then if you need to check them, this is where you check the conditions. So we are assuming that all the conditions are met because they tell us that in the problem. So we will do a t-test for the slope of beta. Next is the do. We're going to, if you look at the output for the body weight, we're talking about the slope. We see that the t value is already calculated for us, and that's 3.21. And we know that our p value is 0.018. And we know that the degrees of freedom, these are observations of 8 students, because they tell us we have 8 randomly selected students. So our degrees of freedom, remember, is n minus 2. So our degrees of freedom will be 6. The last thing we're going to do is draw our conclusions based on that p-value. So since our p-value of 0.018 is less than our alpha of 0.05, we're going to reject the null hypothesis and conclude that there is convincing evidence of a linear relationship between body weight and backpack weight for 9th grade students at the school. Would a 99% confidence interval for the slope beta of this population regression line include 0? Justify your answer. So yes, the 99% confidence interval would contain 0 Because the p-value of the two-sided test is greater than 0.05. And this should say, because this was an alpha equals 0. Because our p-value is greater than 0.01, that's why we can do the 99%. So it would contain 0.